A capacitor C is connected to two equal resistances as shown in figure. What is the ratio of the time constant during charging and discharging of the capacitance? Charging means when we close this switch. Okay, so when we close this switch, you can see that what is happening, that here in this branch, one resistance R and C capacitor and this battery. These three are forming a single loop, and this particular resistance which is connected between these 2 points is also connected in parallel with this RC circuit. So in a nutshell, we know that when we switch is closed, then this R is connected to this battery and this RC is independently connected in parallel to this battery. So as far as the charging circuit of this capacitor is concerned, this loop will do, and it won't affect its time constant, because this thing and these two are connected in parallel, and parallel the things are independent. So time constant in first case, when it is a case of charging, in case of charging, time constant will be simply RC. Okay, RC, which is connected in with E battery. And when after charging, when we open this switch, then what happens? This battery goes out of the circuit, and here this particular loop gets connected. So it will be a case when a charged capacitor is connected to a 2R resistance, because these two will be in series. So what will be the time constant in that case? Resistance of the circuit has become 2R and the capacity is C. So the time constant during charging, which is τ1 is to τ2 during discharging, is equal to 1 is to 2. So option C has to be the correct option.